Hey folks, today we're going to talk about calculating molar mass. There aren't a lot of slides here, but there is a lot of math, and so please make sure you have some paper. You're going to be taking some notes and doing some math with me. Okay. First thing we need to talk about is how do you calculate molar mass? Now, you all know the answer to this. How do you calculate molar mass? Well, let's say that I gave you H2O. How much does H2O weigh? You say, well, duh. That's 1.0079 times 2 plus 15.999, because that's hydrogen, mass of hydrogen times 2 plus the mass of oxygen, and it's 18.015, and that's grams per mole. So clearly you know how to do that, no question. So what's the big deal? Well, here's the question. What if I don't give you that? You have to know it's two H's and an O to be able to calculate your molar mass. Well, let's say I didn't give you the H, and I told you to figure it out. Well, that's what we're going to be talking about how to do now. All right? So remember that molar mass, and we're going to talk about this a couple of times, molar mass is grams per mole. And that is key to what we're going to be talking about today. All right. To calculate molar mass, you probably should pause the video and write these steps down. To calculate the molar mass, you have to write and balance an equation. You have to write down what you know. You have to convert to moles of the mystery compound. You'll understand that in a minute. And again, here's, as you look at this one, this is key. Molar mass is grams per mole, so you have to know that. And then you might have to solve for an unknown element. I'll show you how to do that. All right, so the best way to do this is actually go through an example. So we have a total of 2 examples we're going to be going through today. You're starting with 9.23 grams of an unknown metal chloride. Well, because I don't know what the metal is, it's just some metal, I'm going to call it M for right now. So I've got a metal chloride reacts with excess lead 2 nitrate, PbNO3, and it said lead 2, that means lead has a +2 charge. Nitrate we know has a -1 charge, so that's PbNO3 2. To produce 24.3 grams of lead 2 chloride, well that's PbCl, and chlorine has a -1 charge, lead has a +2, so it's PbCl2. And another compound. Well, clearly what we have here is a double replacement reaction, so I'm going to have the metal going with the nitrate. Okay, so far so good. Now, it tells us that the metal has a 3+ charge. Well, if the metal has a 3+ charge and chlorine has a -1, that has to be my metal Cl3. Similarly over here, nitrate has a -1 charge, so I'm going to have 3 of those. So I've balanced the charges on each of my compounds, but now I have to go back and balance the things that I have. I notice that I have 2 nitrates here, and I've got 3 nitrates on the right. So to do that, I have to have a total of 6 nitrates. So I balance my 3s and my 2s. Well, that means I've got 3 leads. That means I've got 6 chlorines and 2 metals. So I am now balanced. So here is my balanced chemical equation. Now, what do I know? Well, I've got 9.23 grams of my unknown metal, so I'm going to end up with 9.23 grams of this stuff. And I also know that I have 24.3 grams of lead chloride, lead 2 chloride. Right? And I'm trying to figure out what my metal is. That's what I'm trying to figure out over here. Make sure we understand that's a 2. Okay, so how do we do that? Well, we've gone through the first 2 steps. The first step said to write down our balanced equation, and the second step said to write down everything that we know. Well, we've done that, and now our third step is to convert to moles of the mystery compound. So I'm trying to convert to moles of MCl3, which is over here. So I'm trying to convert to moles of this, and the only way to do that is to convert from moles of this stuff. Well, I can figure out what the mass of lead 2 chloride is. So if you sit down and you look at your periodic table and you can figure that out, this is, I'm not going to waste your time doing it with a calculator in front of you, but that's 278.106 grams per mole. Well, that's good, so that means I can now take my 24.3 grams of PbCl2 and I can convert to moles. And I want to convert to moles of this metal thing over here. right? So let's go ahead and do that. That's a simple stoichiometry problem. We start with 24.3 grams of PbCl2, and I have to convert from grams of PbCl2 to moles of PbCl2, to moles of PbCl2. But I don't want moles of PbCl2. I want moles of my mystery compound. So my moles of my MCl3. All right, well, let's see what I can fill in here. 1 mole of lead 2 chloride weighs 278.106, so that number goes here. And I've got 3 moles of PbCl2 are producing 2 moles of the metal chloride. So if I plug this into my calculator and work it out, I get 0.0583 moles of MCl3. Okay, well now I'm stuck. Well, how does that tell me what M is? Well, it doesn't. But remember what molar mass is. Molar mass is grams per mole. Well, what do I know? Well, I know that there are 9.23 grams of this stuff, and I know that I have 0.0583 moles of it. So if I do that division, what I come up with, and again, I'll save you the time, this is 158.319 grams per mole of MCl3. That still doesn't tell me what the metal is. Ah, but wait, we have 3 chlorines over here in MCl3. Well, I can figure out what 3 chlorines weigh. So if I take the 158.319 and I subtract out 3 chlorines, which is 3 times 35.453, because each chlorine weighs 35.453, I subtract that, what I get is I get 51.96 grams, and that's what my per mole of my metal. Really? All right, well, let's go look at a periodic table and see if we can find something that weighs about 52 that has a +3 charge. So I look at my periodic table and I look for something that weighs about 52 that has a +3 charge, and doggone, I found, well, I can't write in white, it's chromium. You guys can see a, what do you call it, an arrow, which I can't see. But anyway, that's what you have. You have chromium there, and it weighs 51.996, which is right about what we're looking for. Right, 51.96. So, gosh, that's really good. So that tells us that our metal up here is going to be chromium. All right, let's do one more, but this time I'd like you to do it. All right, so if you would, pause the video and see if you can come up with the balanced chemical equation and write down the information you know. All right, hopefully you did that. It doesn't do you any good to just watch me do it. Hopefully you're doing some of this. So we're creating a metal nitrate. So that's a metal, and that's nitrate. And it reacts with ammonium carbonate, which is NH4CO3. I'm going to ignore charges for the minute. And what it's going to produce is it's going to produce ammonium nitrate, which is NH4NO3, and another compound. Clearly this is a double replacement reaction, so I'm producing a metal with a carbonate. All right, now the other key piece is that we have a 2+ charge on our metal. So since the metal has a +2 and nitrate has a -1, I have to have 2 nitrates. Ammonium carbonate. Ammonium is a +1, carbonate's a -2, so I have to have 2 ammoniums. This over here is +1, -1, and the metal is +2, -2, so they cancel each other out. So I'm done balancing my charges. Now I have to balance my reaction, and I notice I have 2 nitrates and 2 ammoniums, so I have to put a 2 in front of there, and I'm now done. All right. So let's write down some information. I have 8.70 grams of this stuff over here, my metal, 8.70 grams. And over here I have 7.43 grams of ammonium nitrate. So I have 7.43 grams of ammonium nitrates that's produced. And that's what I know, and that's as far as I can get so far. All right. Now, if you just watch me put that down, so go ahead and pause the video now and see if you can figure out the next step. Okay, the next step is clearly I have to figure out how much ammonium nitrate weighs. And I've done that on the side, so I don't want to waste your time again doing that. So ammonium nitrate weighs 80.043 grams per mole. All right, can you set up the stoichiometry problem to get to moles of this stuff, to get to moles of the metal? Try it on your own. All right, so we start with 7.43 grams of my ammonium nitrate. And I want to convert from grams of ammonium nitrate to moles of ammonium nitrate. But I don't want moles of ammonium nitrate. I want to go to moles of my metal, which is my metal nitrate. 3,2. Right. So what information do I know? Well, I know that 1 mole of ammonium nitrate weighs 80 grams, 80.043 grams, and I know that for every 2 moles of ammonium nitrate, I produce 1 mole of my metal nitrate. Now, if I do that math, I come up with 0.046464 moles of my metal nitrate. All right. Well, remember what to do next. Pause the video, see if you can do it. All right. What we do now is we come up with our molar mass, and our molar mass is grams per mole. And we know that we have 8.70 grams of our metal nitrate, and we have 0.0464 moles of our metal nitrate. So if we divide those two things, we come up with 187.5 grams. Well, now we're pretty close. Now what we have to do is we have to figure out how much the metal weighs. So we're going to subtract out the nitrogen. We have to subtract out 14.007, but we've got 2 of them in there. So we have to subtract 14.007 times 2. And then we have to subtract out 15.999 because that's oxygen, and we've got 6 of those. We have to subtract all those out. When we subtract those out, our metal ends up being 63.5 grams. Well, do we have a metal that's 63.5 grams that takes on a +2 charge? Well, let's look. 63.5. Good gosh, we sure do. It's way over here. It's copper. That's a number you should be pretty familiar with. We use it a lot. Copper is 63.5 grams. So we have determined that this is going to be Cu. So this thing up here is copper nitrate, copper 2 nitrate, Cu2, copper 2. All right. So it's going to be copper 2 nitrate. All right. Guys, I realize we've done a lot, right? But if you are still confused, go watch it again potentially, or go off and try and do the worksheets, and there are podcasts for each worksheet, so that should help you figure out what's going on there. All right? If you have questions, please see us in class. And this obviously is clearly making you think. So ask us if you need help. We'll be happy to explain it more. All right? Take care. Have a good day. Bye-bye.